All right, let's look at the practice exam 3, problem number 9. All right, so we want to use a convolution property to find the inverse Laplace transform of 1 over s squared, quantity s squared plus k squared. All right, so here's the hint. So Laplace transform of the convolution is going to be a product of the Laplace transforms. All right, so think of this as, I'm going to let this guy to be, say, capital F sub s. And then this is going to be, say, capital G sub s, right? So we know that if you take the inverse Laplace transform of the product of, say, capital F sub s times capital G sub s, right? And this is going to be equal to inverse Laplace transform. So you get the convolution between f of t and g of t, right? Right, so let's do that. All right, so if you look at this expression here, we can split it into as a product, right? So you have a 1 over s squared times quantity s squared plus k squared, right? So this can be rewritten as, so 1 over s squared, right, times 1 over, so it's going to be 1 over s squared plus k squared. All right, so we take this guy as, so this is going to be our, say, capital F sub s, right? And this is going to be our, say, capital G sub s, right? So we want to find, let's say, f of t, right? So by taking the inverse Laplace transform of that, you get f of t is going to be equal to, right? So inverse Laplace transform of 1 over s squared would be just a t, right? Here I have to do a little bit of rewriting. I have to put a k on top and divide by k. So then inverse Laplace transform of that would be, so this is going to be our g of t. It's going to be 1 over k. Then that's going to be a sine of kt. Is that okay? All right, then all you have to do is we just have to evaluate the convolution. So let's do f of t, right? Convolution with g of t. This is what we're looking for. All right, so this is going to be, all right, so it's going to be an integral from 0 to t. All right, so it's a t, so it's going to be tau times g of t is 1 over k. So I'm going to put, let's see, 1 over k outside. I'm going to put the 1 over k here. Here's 1 over k. All right, sine of k. All right, here's the t minus tau, right? So I have to put the bracket here and bracket there, and then with respect to tau, right? So that's just following the definition. All right, so let's use the integration by parts, right? So I'm gonna let u to be this guy, right? dv to be the rest of it. So here's a dv, right? So let u be tau, right? And if you take the derivative, you have a du over d tau, which is going to be derivative of tau with respect to tau would be 1. Then we can multiply through by d tau. So du is the same thing as d tau, right? And then we have a dv is equal to, right, you have a 1 over k sine of, right, k times t minus tau dt, d tau. And if you divide through by d tau, you get the dv over d tau is equal to, right, 1 over k sine of k times t minus tau, right? Then if you take the antiderivative with respect to tau, you're going to get v is equal to, right, antiderivative of this. So 1 over k is just going to be a constant, so I'll leave it there. Antiderivative of sine is negative cosine, right, of, same thing, k times t minus tau. But you would have to divide by negative k. So we're going to have a negative k, so it's going to be positive. So you have another k, so put 2 there, right? All right, so we need to complete the integration by parts. We need the u here. We need du, and we need v here. All right, so let's compute this. So this is 2, right? So uv, so this times that. So we have over k squared, right? Cosine of k times t minus tau, right? And then you're going from 0 to t, right? And a minus integral from 0 to t, right? Then you have a 1 over k squared cosine of k times t minus tau with respect to tau, right? Then this is going to be equal to, right? If you plug in t here, you have, let's see, t minus t, so it's going to be cosine of 0, which is 1. So you have t over k squared. Right? If you plug in 0, the whole thing is 0, so it's minus 0. Right? Minus, right? Antiderivative of this guy is going to be, antiderivative cosine is sine of k times t minus tau, right? But you would have to divide by negative k. So I'm going to make it the positive and k. Then we still have 1 over k squared, so it's going to be cubed, right? Then you're going from 0 to t, right? So this is going to be equal to, right? So you have a t over k squared, and then plus, right? If you plug in t, so t minus t is 0, sine of 0 is 0, so it's actually 0, minus, if you plug in 0, you're going to get the sine of k times t minus tau over, right? And then, oh, actually, sorry, I forgot to put the, so if you plug in 0, you're going to get the kt, and then over k cubed, right? So if you want, we can pull out the 1 over k cubed. Then you would have an extra k, so you have a kt minus sine of kt, right? So that's the inverse Laplace transform of the given expression. Right? That's it. I hope that this was clear.